ChatGPT, Gemini, Llama, Claude. You've heard all of these names. They're large language models that have completely transformed the way we work and think about technology. Companies are now building their own large language models with hopes of transforming their businesses into more productive, efficient, and innovative entities. But how do these models actually work? And more importantly, what does that mean for your business? Today, I'll be joined by a pair of Stanford PhDs and experts from worldwide technology, Vaughan and Jason Lu, who have been studying these models for years. They'll explain the core concepts that power LLMs and how these models are already being used to boost productivity and efficiency in the enterprise. We'll also grapple with big questions, like as LLMs become more advanced, how close are we to true artificial general intelligence? And what are the security and ethical implications we need to consider? This is a conversation that will challenge your assumptions and leave you with a deeper understanding of the AI revolution unfolding all around us. So let's take a peek under the hood of these incredible machines. This is the AI Proving Ground podcast from Worldwide Technology. Everything AI, all in one place. I'm your host, Brian Felt. Let's get started. The two of you are scientists by training, I believe. You've been studying LLMs, AI for a while now. So based on your understanding of AI or large language models, give me a hypothesis for the future of what you expect to unfold with LLMs. Yeah, Brian, you go ahead.
About a year and a half ago, I was asked the same question at a panel discussion. And at that panel discussion, Jason Lu said that he thought that we would start to see artificial general intelligence, which is models that have actual reasoning capability within 2 years. My response to that was, I think that's overly optimistic, but betting against Jason Lu is usually not a good thing. And I think as we'll see in today's discussion, that's already reality. So I think what we're going to see is that the reasoning engines are going to get increasingly sophisticated, that they're going to get integrated with other packages that are going to give it capabilities to do mathematical tasks, for example, that are going to require call-outs. And I think as a human being would do. So I think we're going to see them endowed with a lot of the same access that humans are going to have, and it's going to start to look more and more human over the next months and years.
Yeah, Jason, put your lab coat back on and give me your theory.
Yeah, so even as of today, we already have some rudimentary approximation to AGI, artificial general intelligence. So the usage that we can apply with the LLM is for brainstorming. Yeah, so it's like a personal brainstorming assistant. So it's becoming very useful now. If you have some ideas you want to check, you can brainstorm with LLMs and give you extremely good background information and help you to think about new approaches. Yeah.
Yeah. Mm-hmm. Brian, before because I know the conversation we're going to have here today is going to talk about kind of the inner workings of large language models, why it's important, and just in general what it means. But things are moving so quickly. There's so many, terms or models, whether it's LLMs, small language models, AI agents, reasoning models. I think you just mentioned, symbolic AI. Like maybe Brian level set for me on what's the relationship between all these types of terms or models, or is there one?
Fundamentally, they're all based on the same computational architecture, which is deep neural network, which is a neural network that has many different layers. And Jason, I think, is going to talk more depth about what that means. But as people understand the inner workings of those better, they're able to build these innovations. And a lot of them are fundamentally applying that technology. An agent is simply giving a lot of separate language models or a lot of separate AI tools, discrete tasks to do, just as you would in a corporation when you're dividing the tasks that it takes to accomplish something. So they're all fundamentally based on the same computational architecture, these GPU-powered environments. But Jason, would you agree with that, or do you think that we're seeing something new?
So the transformer algorithm is the engine, is the secret sauce behind all the modern LLMs. What we are doing differently in these last 3 years is how we train the LLMs. We have new approaches to train the LLMs.
I mean, for lack of a better way to describe it, the way information is processed, like different ways to process information?
Different way of teaching machines how to think. Before we have more like an equal voting approach, and nowadays we are emphasizing the expert opinions, okay, the really smart people's way of thinking, and teaching machines to think the same way. Yeah.
One thing most people don't realize is that machines didn't teach themselves, that they were trained with the help of thousands and thousands of people who would evaluate their responses until they got better and better and better, because ultimately we're asking them to mimic human thinking and to be able to answer questions in a way that we as humans would evaluate it as correct. And so this human side of the training, I think, is unrecognized by a lot of people. But I don't know how many people were involved, Jason. It was a lot.
Yeah, a lot.
Well, why is it important that we process it in different ways? Or is it important? Is it just like a natural continuation on we're training machines in different ways? But why? Is there an importance to training machines in different ways?
Yes. I mean, because most people, when they think, when they make discussions, is very direct, okay, one-dimensional. But the real experts, in the real thinkers, okay, they think in some sort of tree fashion. They explore different directions. They reason in a much more elaborate way, and we want to teach machines to think that way.
I mean, Jason, over breakfast this morning, you shared an example with me of something that you discovered, or you just in the last couple of days. Now might be an interesting time to talk about that. The interesting analogy that you discovered.
Yeah, they are two examples I cited to you. Are you referring to the reverse thinking?
Or the
reverse thinking or
colorblindness.
colorblind? Okay, colorblind thing. Yeah, so I was always very interested in colorblindness in humans. And there is a conjecture that colorblind people help in combat situations, especially during camouflage situations at the night attacks. Okay, and the camouflage people, colorblind people can actually see through camouflage and see better at night at dim light. And so tribe, without the colorblind people, they are basically eliminated, okay, through the history. And at the end, every single tribe are equally endowed with colorblind people. And I asked ChatGPT Model 03 whether in that situation, the prevalence rate of the colorblindness will become stable. And it not only answers with a very smart answer, okay, it actually gave me the keyword, okay, called the Hardy-Weinberg equilibrium. I didn't know that term, and it explained to me, yes, the prevalence rate will stabilize. Yeah.
Well, okay, so walk me through what the colorblind analogy means for our understanding of, would it be LLMs or AI in general?
So this is for language models, and I think actually this gets to one of the main topics today, which is the inner workings of LLM. So I think once you've gone through that, Jason, especially the dewdrop analogy, will start to illuminate how that works. So why don't we let Jason describe
and just
that.
real quick, Jason, before you start, Brian, why would it be important that we would need to know the inner workings of these language models, which are, such a force for driving productivity and seemingly even more potential? Why would it be important for our viewers, listeners, anybody to know this stuff?
To understand, especially for a business user, to be able to make a good decision, or to advise, as a leader, to advise the company on what they can and cannot do, or should not be doing with language models, or with artificial intelligence in general, having an understanding of how they work, I think, gives you an appreciation of what they can do, what they can do especially well, what they can't necessarily do any better than a conventional algorithm, and then what some of the challenges are that you need to be prepared for so that you can ensure you get reliable results. So I think business leaders or users, by having an understanding of the inner workings, can make a better decision on whether it's the right tool and how to use that tool appropriately. Obviously, for a practitioner, you need to understand the inner workings so we can build 04 and 05 and 06.
Yeah. Well, I like that, because we've heard time and time again the idea or the concept of, generative AI just being kind of an intern or a newly onboarded employee, and you wouldn't bring on a new employee without any understanding of what they can or cannot do or what they're capable of. So it's kind of similar.
It's a good analogy. Yeah.
Yeah. Well, Jason, walk us through. Give us a little bit of an elevator pitch. You don't have to go too deep here right away, but walk me through that inner workings.
There are two details that I would like to explain about the LLM algorithms. One is the concept of renormalization. How through the algorithm we can form and build concepts out of raw data, and the second part is the heart of the transformer algorithm, which is the attention mechanism. Yeah, so those are two technical aspects that I would like to address. And after that, we can discuss more about DeepSeek and the reasoning engines, which are the new development in this field.
Yeah. We'll get into it. Start with, I think you said you were going to start with reductionism there. So tell us about that and what it means in terms of the ability of a language model to start to understand what each word, number, whatever means.
Yeah. So the thing that enables us to use LLMs is we convert word tokens into embedded vectors. So we translate the words into mathematical arrays of numbers, and that mechanism is called embedding of tokens. Yeah, and for that purpose, we use an approach in it's a little bit philosophical. We call it reductionism. We call it holism instead of reductionism. Yeah, and through that approach, basically, we look at the neighbors of a given word, okay, and build array of numbers that way. So it's a correlation of other words to that missing word. Yeah. And after that, okay, when we have the embedded vectors, we pipe it through many layers, deep layers of neural network. And that's where renormalization process happens. And let me describe a little bit what renormalization means. Yeah. Let me give an example. In the early morning, okay, we have moisture in the air, and this moisture will be piling up on the leaves. Yeah. So we have very fine droplet at the beginning on the entire surface of the leaf. But as the night progresses, then these leaves grow in size, they start to touch each other. So we have a bigger and bigger drops of water on the leaf. By the time the sun rises, we have very few big drop of water. Yeah. That process is what we call in physics renormalization, the formation of big quantities, okay, from smaller entities. And that's exactly the same process that the deep layers are doing, okay, in forming concepts out of the raw data that is going into the algorithm. Yeah, the raw data could be the pixel values of images, or in the case of LLM, they could be the embedded vectors of the words. Yeah.
Why is the renormalization critical to this process? Would it be because the reductionism would be overwhelming for any model to start to understand, and therefore it needs to renormalize it so that it understands, what cat might mean versus dog?
Yeah, exactly. During the renormalization process, we prune out, we eliminate all the irrelevant signals, and then at a higher and deeper layer, then we have fewer and fewer concepts. At the end, we have a reduced set of concepts, and that's how our brain works, actually. Yeah. Mm-hmm.
Yeah. Get into attention and coupling too, because that seems to be a very important part as well.
Yeah. Yeah, and so LLM algorithms are based on a approach called transformers. And transformers are based on a algorithm called the attention layer. Yeah, and let me try to use an analogy to describe the attention layer. So when we have an electron traveling in a magnetic field, say from left to right, and we have a magnetic field pointing up. Yeah. And the direction of the force actually is perpendicular. It's in a third dimension from the direction of the velocity of the electron, and perpendicular also to the direction of the magnetic field. So the force happens in the third dimension. Yeah, and borrowing the same idea, we implement the attention layer in LLMs. So the idea is we have words in a paragraph, and these words will be attracting or repelling each other. Yeah, and we implement all these forces, gazillions of these forces throughout the attention layer. So the words will start to get close to each other or get far away from each other, pretty much like a protein folding. Yeah, so that's a good analogy. Yeah, so for some example, we already talked about 2 drops, okay? And in the case of LLMs, it's a little bit closer to what we see in biology called the ribosomes, okay? Ribosomes are very interesting because ribosomes themselves are made of RNA molecules and as well as amino acid protein molecules. And but them themselves, once you form the ribosome, it can process other RNA molecules and generate the protein molecules, okay? So that's the interesting part about LLMs. There's no separation between programs and data. Yeah, in the LLM world, okay, right? It's like a ribosome itself is made of, basic units of chemistry, okay? But it itself becomes a factory that can process other data. Yeah, and in the LLM world, we have the same situation. We have the prompts, and the prompts at the end, inside the core of the algorithm, the prompts become like a ribosome molecule, and it can process other parts of the text and generate new text.
Yeah. Brian, let's tie it to the business here a little bit. And I wrote this part down, so I'm going to read it off my computer. If reductionism is taking into account all like the individual data points of a business or their customers or their partners or whatever it might be, then the holism would be bringing it, would be start to making sense of it with business insights, whether it be behavioral trends, market predictions, whatever it might be. Renormalization would be tying it back together. That's when it starts to become like business intelligence. Mm-hmm. And then the attention and coupling is just actually making that actionable. Would that be in the neighborhood of right? Or how would you describe, what Jason just said to a business that's wanting to actually put this into action?
I would change that last word from actionable to either actionable or comprehensible. A lot of what customers are using language models for is to retrieve information from a large corpus of corporate data. It could come from dozens of different data sources, from ServiceNow, from HR systems, from payroll systems, from wherever, and using language models both to retrieve information and to summarize that information, and sometimes even to make decisions about that information based on a human question, based on just a typed in or spoken question. Now think about that compared with what we did in the old days. In the old days, we'd write an SQL query, or we'd find a colleague who knows how to write SQL and has the right privileges to write SQL to go write a query and pull something out of a structured database. If we wanted to retrieve information that was just sitting in a document somewhere, we had to go find it, read it, or get someone else to read it, summarize it, and then ultimately make a decision. So what the language models are now allowing us to do, if we've ingested that data, is now a human being can ask a question in plain language, have it retrieve appropriate documents, summarize those documents, and answer questions about those documents. And I would say probably 70 or 80% of the business uses that we're seeing right now of language models are related to some combination of those things. I've yet to see a customer relinquishing control of the business to AI. But as Jason said, it's a great brainstorming tool. You can use it to retrieve information. You could even ask it a question like, is this consistent with our corporate values, for example? And it could give you a comprehensible answer if it's ingested those values, as an example.
Yeah. What else are you seeing in terms of use cases on the market now, either with, clients we've worked with, and we don't have to name names, but what are we seeing the most practical or innovative uses of these language models?
Some of the really innovative cases that we're seeing, we have a couple of customers now that are using it actually to improve IT operations of all things. You think that's about as far removed from language as you can imagine, but take the case of a network operations center where you're constantly dealing with messages and constantly dealing with inquiries from human beings that are in human readable languages, or log files that are ultimately human readable. And so we're actually using it for alerting systems to help human beings take an event, like an IT event, ingest all the data and make sense of that data. So better get to root cause analysis, or even look for early warnings of an IET incident. We're seeing the same thing being done in health and safety for customers who are using operations data instead of IT data, and doing very much the same thing, being able to piece back using this human readable information, what happened, what's the likely root cause, and what are some early indicators of challenges. And then finally, we have customers who are using the multimodal capabilities of the modern language models like O4 that can actually interpret diagrams to help people find parts. Like, hey, I need the part from this engine that connects the flange to this other piece. What's the part? And it can actually, having ingested those diagrams, can actually look up part numbers, and saving customers a lot of time. So it's really an efficiency tool in all these cases.
I do want to touch on ROI. I know that's not necessarily the basis of what we're here talking about today, but so many of the conversations as it relates to AI, especially when you're involving, real world organizations, go back to ROI. Yeah. So time, it feels like that's a little bit of a subjective, like, how do you value the time if it's an efficiency tool right now?
I'll take that. I can take that.
You can do it.
Well, one of them is, it's tricky to calculate the ROI on an efficiency tool. I had a customer once who was very rigorous about it, and we talked about, hey, we're saving this many hours here. And he said, I only save money when I'm either not hiring somebody or I'm letting somebody go. And that's a very challenging metric. I've yet to do a project where we came up with an output and the customer says, great, I'm going to let my whole department go because the AI is doing it. That's not the case. What we're fundamentally allowing people to do is to do their job better and spend their time on the tasks that they were really trained for, not sort of the more mechanical tasks, and do those tasks better as a result. Is it easy or hard to measure the ROI? It's difficult to measure the ROI. You can certainly measure time savings, but converting that to an actual dollar savings is challenging. Now, to the extent that you're able to come up with early warning indicators and prevent a network outage, for example, that's a different matter entirely. But then you have the challenge of saying, well, would it or wouldn't it have happened? And if it had happened, how much downtime and what would that have cost? That's a subjective, very subjective. We call it counterfactual sometimes. Or like alternative history, right, is always very challenging. But customers are quite comfortable saying that some of these solutions that we've helped them develop to save them millions of dollars because it's really helping them to manage their operations better and preventing problems. Mm-hmm. But again, it's really hard in this case to associate dollars.
Do you think it'll get easier over time?
Oh, yeah.
Or is it going to become a much more clear path to ROI?
I think if people understand better what they can do and are using them for an increased variety of tasks that, honestly, that people are doing now, it's going to get easier. But it's always going to be hard at the cutting edge to say, okay, well, now we're using it for something we couldn't use it for 3 weeks ago. What value is that creating? That part's always going to be hard.
Yeah. Well, that kind of gets back to your initial statement earlier on, is if you know what it's capable of and what it's good at and what it's not good at, then you can start to, find a swim lane that's going to get you to that value.
I mean, Jason, how many customers are coming to us and say, hey, we've got this cool AI infrastructure and that we employed, and our CEO, our CIO wants us to get value from it. What should we be doing? We see that a lot, and it's frustrating. I find it frustrating. I don't know about you.
Yeah, and so I think our position is people need to put attention to business value. Yeah, it should start with the business value proposal, and then after that, when we have a business value clear, then dive into the technical aspect, technology or hardware that you need to do all this AI work. Yeah, but I think the starting point always need to be the business value. Yeah.
Mm-hmm. Jason, I want to get back to the different phases of the LLM. So, taken together, reductionism, the attention, coupling, renormalization, would that be considered the training of a model?
Both. Yeah, both. It applies both to the training part and to the inference part. Yeah, it's just like training takes a lot more time than inference. Yeah, and in fact, this is a good moment to talk about DeepSeek.
That's where I was going, yeah.
Ah, good. Yeah, DeepSeek basically is an improvement upon the existing algorithm, and it has a few components. Let me go through them. One is they came up with something called multi-head latent attention. Basically, is for the embedding vectors, you can reduce the dimension of those embedding vectors. And then the number of calculation that you need to do is reduced by a factor n squared. Yeah, so it goes down by a factor square, okay, of what your reduction factor is. Yeah, so that speeds up the calculation quite a bit. And then there's also something called mixture experts, which has been applied since a couple of years ago. And the third factor is they do something called KV cache. So we talk about the analogy to electron and magnetic field. Okay, those embedding vectors, you actually can cache them during the inference stage. So you don't need to retrieve them all the time. You can cache them, and that speeds up the calculation. And those are a couple of aspects that made DeepSeek so much faster than what we had before. Yeah.
And I think, the natural follow-up question, at least for me, is how? How did they make it more efficient, speed up those measurements?
Oh, because the length of the numbers, the arrays, or what we call vectors, okay, is so much smaller. Yeah, and because the effect is quadratic, okay, the number of calculation you need to do is 1 or 2 order of magnitudes lower than what has been required previously. Yeah, so that way they can speed up the calculation, not only in inference but also during training stage. Yeah. Mm-hmm.
They also came at it with a different mindset, and I would describe it almost as an old-fashioned mindset. I think all of us who've been in technology a while remember that in the old days when you had a question that you wanted to solve using IT infrastructure, you look at the question. The first question is, do we have the compute, storage, and network capacity to solve this? Okay, how do we have to simplify to the point that we can solve it using the resources we have available, because they were limited? We always thought of ourselves as being compute limited, storage limited, network limited, or all three limited. I think that has changed over the last 5 or 10 years, especially with the advent of high-performance GPU computing. We go into solving problems with the concept that we have unlimited compute power, unlimited storage, and unlimited network. And with these massive data centers and these massive GPU farms, that's almost true. DeepSeek was almost forced by export restrictions to think in terms of, okay, here's what I've got available. Here's the problem I need to solve. How can I solve it with the resources I have available? The way we used to think about problems a decade ago, but I think we've almost gotten out of the habit, because it's a lot easier to just say, okay, well, I'll just throw more compute at it. Now, that's not to take away from the creativity of OpenAI. I mean, what they came up with is extremely novel, but that was the mindset. Yeah. And I think what I hope we're going to see as a result of this innovation is that same sort of efficiency mentality getting applied more broadly, for example, to inference, because especially with the advent of reasoning models, the amount of compute power needed to answer questions is going up and up and up much faster than we can put electricity online.
Yeah.
Right. So at some point, we're going to have to find efficiencies. Yeah. And I think to me, that's a great paradigm shift.
I want to chime in here. We can also look at it from energies or power consumption point of view. Yeah, each one of us humans is like a 100-watt light bulb. Yeah, we require the same power as a 100-watt light bulb, and our brain probably occupy a big fraction of that power. And currently, if we look at the previous version of LLMs, they are using much more power than humans. But we should be able, in the future, to get the power consumption down to equivalent to biological thinking machines, which is us, right? So
Yeah.
And it's not just a little bit more; it's like orders of magnitude more. So that it has to be those efficiencies. I agree with Jason; they have to be there.
Yeah. I do want to get into reasoning with you, Jason, but just to tie off on the efficiency standpoint, what with DeepSeek and the efficiency that we're talking about here, Brian, what does that mean for the business mindset? Like, is it just that this will become cheaper, or this will become faster, or all of the above?
I think we're halfway there. What DeepSeek fundamentally did was to make training more efficient. It doesn't have as big an impact on as inference. Once inference becomes more efficient, then it's going to become much less expensive to ask questions, to apply it. With DeepSeek, it is likely going to be, if you think about the companies, the corporations that are training their own models now, it's a handful of the biggest Fortune 100 global companies that have both the means and the need to do that. Maybe that'll become available to the Fortune, or practical for the Fortune 500. So more companies will be in a position. But paradoxically, as something gets cheaper, more and more, you actually get more and more consumption of it. As inference becomes more cost effective, I think more and more companies are going to be able to do more sophisticated things. Companies now are running into the same challenge that we ran into in the early days of cloud, which is, oh my God, that cloud bill is pretty big, and inference remains expensive. And so I think we're going to have to see that same innovation applied on the inference side to drive much more significant adoption. Because at some point, if everybody in the company starts using it all the time with the current generation of models, it's going to be prohibitively expensive.
Yeah, well,
and as Jason said, consume prohibitive amounts of power.
Yeah, I mean, that's getting into Vaughan's paradox there,
Exactly.
Which is, if it's more efficient and cheaper, that's going to open it up to the masses.
Exactly.
But then if a 7,000 person company, if everybody's utilizing it, then it's still going to use and gobble up more compute.
Yep. I think for Vaughan's paradox to apply here, we're going to have to get that same efficiency on the inference side. Jason, you may disagree, but that's what I'm seeing.
Yeah.
Well, what's the path to that, or what's the likelihood, or where do we stand in terms of getting that inference down?
It's already down, and there's still room to go further down. And so we can foresee that we can do more with the same power. Now we can do more, and so the usage of all these AI tools will be even more widespread, and we can do deeper analysis. So as you said, it's like the fact that the energy is becoming more efficient for LLMs will lead to further usage.
One thing I got to credit DeepSeek with is open sourcing the code, and that will inevitably, as we've seen time and again, that will inevitably create more innovation, because now you've got the entire open source community who's going to be trying to achieve that innovation. So I'm hoping that accelerates the innovation, and I'm hoping that one of the things that we focus on is efficiency. I mean, if you're a Ferrari, you don't worry about efficiency. You worry about building a faster and faster and better car. But I'm hoping that we'll get the Toyota makers and the Honda makers and the Ford makers out there are going to be looking for opportunities to be efficient, because that's where we're going to get the adoption, and that's where we're going to see the impact.
Is that signaling that we're in for more and more DeepSeek type announcements coming out on a more rapid pace?
I think so, and my head's already spinning. I think our heads are going to spin even faster trying to keep up with the innovation.
Yeah, maybe not necessarily in your domains here, but what does that mean from an IT standpoint? Like, how do you keep up with a new model or a more efficient model always coming out? It just seems like it's just, a whirlwind.
Yeah, so this morning we were discussing exactly about that. Is people are getting oversaturated with all the new innovations. It's becoming hard to catch up. Yeah, it's becoming hard to catch up. You need dedicated people to follow up with all the latest developments. And we are, in fact, inside already in what we call technological singularity. So, yeah, it's hard to catch up.
Technological singularity. Yep. What is that?
That's
it sounds scary.
Yeah, that's because what we observe is like the amount of information exchange is growing exponentially. Yeah. So at some point, it's like you hit the singularity where the information exchange is so fast that nobody can really catch up. Yeah.
Yeah. Well, that's ominous for sure.
Yep.
I promised that we'd get into reasoning. So where does reasoning, is that just the next logical layer that is?
Yeah, and it's already happening. It's happening with OpenAI's ChatGPT version 03, and it's happening with DeepSeek's version R1. Okay, both versions are large language model with reasoning capabilities. Yeah. So reasoning is a new development in the LLM world. It came about with something called chain of thought. Okay, so we are training LLMs not just to provide an answer. We are training LLMs to provide also the reasoning steps. Yeah. So the output of the new LLMs is not just the plain answer, but it gives you also the thought, intermediate thought that leads to that particular answer. So this is a new way of training LLMs. So an analogy I like to use is like in the old days, when you have prompts, those prompts are converted into ribosome-like factories, and then they can process the rest of the text. And with the new way of training LLMs, we are generating what I would call a hyperribosome. And these hyperribosomes are thinking engines that are not only process the word tokens, these hyperribosomes are processing chain of ribosomes. So they are not processing the raw information anymore. They are processing chain of thoughts, okay? And those chain of thoughts then process the underlying information. So it's a two-layer thinking process now. And that approach is very powerful. That mimics the way how great thinkers, okay, great scientists, how they think, and that we are teaching LLMs to think like a very sophisticated scientist.
There's a book that came out a decade maybe ago called Thinking Slow and Thinking Fast. Mm-hmm. And it describes two types of human thinking. Thinking fast is like instinctual thinking. You ask a question and you just answer it. It's particularly in like fight or flight type situations or just day-to-day, casual situations. We do a lot of fast thinking. Slow thinking is thoughtful, multi-step thinking, the way Jason was describing, the reasoning thinking, chain of thought. You think about this, you think about the consequences, play out different scenarios. That's called thinking slow. And what we had seen in the early LLMs, the early language models, they were thinking fast. Yes, they gave us pretty sophisticated responses, but ultimately they were just predicting the next word and ultimately coming up with the first thing that came to mind, if you want to use a human analogy. These reasoning engines, these chain of thought engines, are doing what a human would do, is to think about it, think about different ways of thinking about it, different ways of looking at it, weighing those, and coming up with a response. And so it's now, I think, mimicking both types of human thinking.
Yeah. From a business perspective, do you always need the reasoning? You mentioned how, earlier, Brian, about it's an efficiency tool. Do businesses always need the reasoning that an AI can provide?
I think right now it's good enough to be, as Jason described, a brainstorming assistant. It's always helpful in making a business decision or to have someone to talk to you. Call, hey, can you come over here and help me think this through? I think we're already there, and I think that sophisticated customers, I think, or sophisticated businesses are going to start doing that and using it to help make better decisions. So I think it is valuable because it has, not only does it now mimic a human way of thinking, it has access to the whole corpus of corporate data. No matter how long you've been at a company, you don't have all of that up in there.
Yeah, and with the reasoning skills, we can give access to like a fuzzy or how can I say it, the more advanced territories, like especially in the legal ambit, okay? Because these reasoning engines can give you explanation about very vague concepts like values, corporate values and things like that, and you can reason through it, which before was not really possible.
Yeah. Where Where does agentic AI fall in here? If an AI model is reasoning and it's working through what's the best way to answer this, or what's the best way to go about figuring out what the prompt wanted, once it can pull from different AIs in an agentic manner, is that just extrapolating the power of an AI, or am I just going down a dead end right now?
Yeah, I mean, I would view it as an analogy is like the running of a company. Yeah, in a company, you need salespeople. Okay, you have the CEO, the management layer, and you have the IT support, IT department, also product development, R&D department. Each department is responsible for different aspects of the company. And I think the agentic approach is exactly the same way. We want to specialize. We want different departments to specialize in different tasks. And for that application, agentic approach is important.
Yeah, an executive may ultimately need to make a decision, but they're going to need information from all those departments. They might want input from all those departments. They might even call a vote of all those departments to come to a decision. I would say the agent, if I'm going to extend your analogy, but would be a bit like those departments, but then the reasoning engine is playing the part of the executive in that analogy.
Yeah. Well, at what point are, we mere humans just rendered not needed in our civilization as we know it?
There's still one more step to go. We have initial version of AGI, which is very useful for us to brainstorm with. Yeah, we can get help from the LLMs in our daily thinking process. But today, those machines are still not self-aware. Yeah, that's the next frontier. When we make the machines become self-aware, when they have consciousness, then that's the next step. And I hope we stop after that because we humans, I hope we humans still exist, okay, a couple generations down the line.
Yeah, AGI, artificial general intelligence. Yeah, I mean, how close is that? Is that going to happen? I mean, it seems like with DeepSeek and everything, things are going to happen faster than we expected. So is that generally going to be true with AGI?
It depends on your definition of AGI. AGI is a very broad term. Yeah, so the version of AGI that allows us to brainstorm with machines, that is already happening. So some basic version of AGI is already happening. It's already here. Yeah, and the next frontier is development of artificial consciousness. That's, I hope, years away. Yeah.
But no doubt there's work being done in that area. If you think about how human beings become conscious, arguably we become conscious by interacting with our environment, seeing how people react to us when we do something, and sort of being aware that, oh, I'm in this separate entity and I have my own ability to make decisions and do things, and people react when I do that. And that's something we have yet to train a machine on, but there's nothing stopping us from doing that. With these multimodal devices, we could create an environment that's very similar to the environment in which we as human beings grew up. And so it's inevitable.
Is that a digital twin? Is that a metaverse? What is the environment?
Call it what you want. I mean, a digital twin is designed to be a digital representation of some physical asset. That physical asset could be one of us. So by that definition, yes, that would be a bit of a digital twin interacting with an environment that itself would be a digital twin. You've seen the movie Tron from however many years ago. In essence, it'd be a sort of creating that universe and letting it interact, and then ultimately just having it develop consciousness. That seems like the path. But as Jason said, I do hope we have enough sense to, because I don't know what's beyond that. I mean, that's kind of where we as humans are. So what's beyond that, I don't know.
It's a little bit similar to the invention of nuclear weapons, right? Once you let the genie out of the box, the situation could be complicated.
Yeah. Well, certainly a lot to think about there. Lots of work to get done as well. Anything else that you thought, maybe I'd ask, or question you'd ask each other before we wrap up?
One point that is important is security, safety, and the intellectual property. That's a very important aspect of all these LLMs, AI tools, because after all, we need to safeguard our intellectual property. So what I see is in the future, all these LLMs will become not as centralized as now, will become a little bit more privatized, or especially for a business environment, because there's intellectual properties to safeguard.
Yeah. Well, I mean, you'll probably say it's at all layers, but where does safeguarding that IP, where does cyber come into the equation when you're talking about reductionism, renormalization, and so forth?
You already entered it everywhere.
Yeah, everywhere. Yeah. Mm-hmm.
Creates an entirely new attack space. Prompt injection. So it's at the prompt layer. When companies start training their own models, then you could potentially corrupt the data that's being used so it's at the data layer. I mean, it's anywhere. And all these new applications that are being developed. When you build a custom application, it's not just GPT-4o. You've got prompt flow. You've got a whole bunch. It's like a whole architecture you need to build around it. And every piece of that architecture and all the interfaces create a new vulnerability that security teams need to be aware of and be prepared to defend, because the attackers are looking for ways to attack it.
Yep.
Both to extract information and potentially even to corrupt that information.
Yeah. Well, we're up on time. So to the two of you, thank you so much for taking the time out and traveling here to GHQ and taking the time to discuss this with me. It was illuminating, and I appreciate it.
All right. Okay. Thank you. Thank you very much. Thank you for inviting us.
Thanks.